Welcome everybody, and thanks for taking time out of your busy day. My name is Bob Council. I'll be the presenter today. I'm just going to get started here. Welcome to a presentation overview, or introduction if you will, very brief, about a product line called 3D Quick Tools. Our product is much more than just 3D, and as you'll see today, it's a revolutionary design approach that really takes into consideration the best usage of 2D, 3D, and automation. So to get started with, let's just talk about what we're going to cover. In the 60 minutes we have together, I'd like to give you as quick of an overview of what the product can do. And that's a heck of a challenge, I'm sure you'll agree. But in a nutshell, we'll talk about the company background, why we're in business, and what our main highlights are. And to get started with, we're 100% focused on die designers. That's all we do, and it's for one product line, and bottom line is that everything that you invest in our product comes back to you in usage that you could take advantage of. Of course, we can also automate your style of die design, which is a heck of a challenge because everybody does things quite differently. And the products that we'll be talking about today get broken down into different areas depending on needs and budget. The flagship product is called 3D Quick Press. There's a complex unfolding technology called 3D Quick Form. We also have a subset for the sales professional called 3D Quick Strip, and another product called 3D Quick Quote for quick unfolding. Our mission at 3D Quick Tools is clear and simple. It's to empower tooling engineers or die designers to use the power of 3D. Of course, 2D is part of that, so you'll still get all your drawings and you'll get all the capabilities that you have today with a current CAD system. We know 3D is needed, and if it's not something that's a favorite topic of yours, unfortunately it's a reality. And that's because product designers are utilizing 3D more than ever. And therefore, you have to leverage that 3D model, or you have to spend time dealing with it in some way. 2D has been a great tool. Unfortunately, there's not much more we can get out of it. The amount of productivity you're going to get out of it for using it many years, and the automation it's given you to date is limited to go beyond the scope because we've proven it. Obviously, it's been many years in usage, and you can only get so fast with it. There are a number of benefits to 3D, and also there's a number of difficulties with 3D. But ultimately, when we get to the manufacturing side of things, our CAM guys, or maybe you're the CAM guy too, the programmers, want to leverage that 3D model so they don't have to recreate it like you may be doing today. So whether it's 2.5 axis machining, drilling and boring and so on, or all the way through 3 to 5 axis freeform milling. So that's why we're in business. Nobody's been focusing on this area of design. There's been a lot of mechanical 3D CAD systems out, and we've gone through many generations, both from technical capabilities all the way through ease of use and pricing. However, the die design environment still is reluctant to go to the 3D tools because of a number of things. First of all, traditionally it's just you're not familiar with it. Second of all, it just doesn't have enough automation to make it quicker in certain cases of 2D. And then of course we have the other factor driving us, which is we have a very strong global economy that is competing on many different areas, including the low cost of labor. So unless we're willing to lower our lifestyle, we need to figure out how to take our value-added hours that we put in and get more productive and more effective with them. We saw this dilemma many years ago, and we did a research project with the Mechanical Engineering Department of the University of Hong Kong. They helped us solve this problem with many of different innovations in the user interface, the speed of the system, the automation of the system, and ultimately reuse of data. SolidWorks was selected after evaluating all the different products out there that, of course, are currently 3D and they have some type of user base. We picked SolidWorks for the best blend of ease of use, great modeling foundation, over 450,000+ users, and it had a very powerful open interface to program in. 3D Quick Tools is a fairly young company, and this may be the first time you heard of us. We were commercialized early in 2003, but since then we've established a distribution and support channel for training and local technical support throughout all major continents, including supporting multiple languages. Just another snippet of why SolidWorks. Just recently, another book of many was released for SolidWorks users. One is called SolidWorks for Dummies, and it was kind of funny. It was a friend of mine that published this, and when they initially released, it went #1 to engineering on Amazon.com very, very quickly, and then it went to #1 on overall topics, including fiction, all books on Amazon.com, which is quite a testimony to its popularity. In a nutshell, 3D Quick Tools provides you a 100% focused development team on your needs. That's unheard of in the market. We can provide a total solution for the sales department through the tooling department. We can help the sales team by helping reduce the cost of sale in the unfolding and the strip layout. We also allow the die designer to focus on the true die design, the operations and the process of the approach. We did this by fine-tuning the CAD system SolidWorks for its 2D and 3D capabilities. We did it through extreme automation of 2D drawings, 3D parts, and assemblies. Not only can you automate it, but you can tailor it to your style of design. You can actually reuse custom designs of your own. This includes the drawings, and there's no programming necessary, and this would be the key factor. Every CAD system you can tailor, but you don't want to become an expert programmer. The results are it's very fast, it's very easy to use, it standardizes the overall process, and you learn the best practices up front, returning a high performance ROI in both the usage and the business benefits. 3D Quick Tools, since we're a fairly young company, it's about 2 major releases. We're about to go into our 3rd major release. We've targeted the mainstay of the industry, the progressive die, transfers, stage tooling, compound, fine blanking, and of course the product spectrums that we all deal with, everything from consumer electronics through automotive, appliances, medical parts, and all the mixtures. Of course, today we only have a few minutes together, so we're going to do a part or a sample part that has different challenges in it, but it's easy in the big scheme of things. So we do invite you to bring to us examples of your dilemmas and your work by sending them to the address on the screen, demo@callsts.com, and we can set up a private presentation and review if our application fits you. 3D Quick Press is our flagship application. Up and beyond the core capabilities of SolidWorks, we've built upon specialty tools for the die designer. Everything from the unfolding, strip layout, punch design, die set structure, and all the 2D issues you have to deal with are highly automated with this application. In the unfolding area, we can import data that was coming from pretty much any source. So when you talk about getting IGES files or STEP files, Parasolid files, all types, you simply open those and we do the unfolding for you. We have a very unique unfolding interface. It has the actual features recognized that are sheet metal orientated features, and of course we can support a number of different conditions both in bending and embossments, round extrudes, metal deformation, coining, gussets, multiple stage forming, and you mix all those together. So what we're going to do here is just show you very quickly, after we import a part, we can run it through the automatic capabilities, and it will then allow you to animate the forming process. You can do this iteratively so you can visualize the process, and you can also do it all at once so you can see the overall steps involved. Now this is not the order, because that's going to be done in the strip. For right now, what we're trying to do is establish the actual features that you want to deal with. Then we can take it to a strip, and as you can see here, we'll give you a little snippet of what's going to happen. We're going to put it into the strip and then allow you to modify the process by modifying the strip or the strip process in regards to the stroke, and of course the lifting and progression level. You have a very, very good interface with the real virtual die. Alright, let's move on to the next example, and what you see here is a very simple automotive type bracket, and of course we can take this part. Now when I say simple, that's simple to us, but you challenge typical CAD system, 99% of the others will have a problem with the metal deformation. We took this part and we created a strip in less than 20 minutes with all the notching and provided it back to the user. They were blown away, and I'll explain why in a moment. Here we have another example. This is just a part of a part. And traditionally, you might have been dealing with 3D, or you may not have. If you have been, you probably use a blank development software that squishes this. The problem is that's not the way it's really made. You typically are going to go through and set up a process of iteratively unfolding it and maintaining circles as circles and so on. We can handle that. And here we have a summary part. We have multiple step forming. We have a series of very simple deformations. And we have some kind of middle of the road issues with gussets on bends and multiple stacked bends. Once we have the part unfolded, we can quickly move to strip layout design. Strip layout design will allow us to put as many blanks into the strip. It can have, of course, no stock, so you can do stage tooling and have multiple tools set up, so it is flexible. Also, you can rearrange the processes. We create all the piercings and the bending and all the different features in it, and then you rearrange how you want to notch it. As you're doing this, you're getting instant feedback as you make changes, such as you want to take a process or two that is in station 3 and dump them in station 1, and you want to see what the results. It's going to give you instant feedback. Also, you want to add and remove stations. Maybe you want to do stock optimization. We can not only nest station to station, but we can nest internally in that station unique parts. All the strike forces, the center of forces, the bending forces can be calculated. You can manipulate the process by splitting up punches, rearranging them, doing partial bends, doing corner matching, adding spring back, piercing and notching after forming operations. So here we see a collection of, or kind of a summary part of a very simple part we'll be going over today. And you can also visualize now, once you start to rearrange the process, you click on an animation button and it animates the forming process in accordance with the press stroke. So you can stop the press stroke anywhere you want, and you can check for interference. You can modify the process, and you can visualize the timing of the die much more accurately. Here's that other strip layout example I mentioned a moment ago, about 20 minutes worth of work, including unfolding and strip development. This was actually a 2D user that went to 3D, bought a really expensive 3D CAD system with a really expensive progressive die add-on, and found out it took longer in 3D than in 2D. But then they saw this application. For a time study comparison, 20 minutes for us, 3.5 hours for them. And their product was 2 to 3 times the cost and learning curve. Now, our strip is much more than just eye candy, if you will. It has got all the properties that you'd want to track about a strip. For instance, the total cutting length of all the notchings and piercings, all the forces, the material utilization, and so on. We also are flexible enough to work with solids or surfaces, so if you have forming stations that have already been developed, you can just throw them in a station and continue the process. We also have a deep draw calculator for primitive type shapes. So you can go through and you can develop the handbook calculations very, very quickly and then create all the stations, predicting the number of stations, whether or not they'll form properly, and then ultimately creating the geometry of each station. And yes, you can include the stretch web. What I've shown you so far is a subset of 3D Quick Press. But I want to stop here just for a moment to let you know this is Quick Strip also. It's a packaging difference, but the price is less because obviously not everybody needs to do the full punch design and die set design. So we can also package this for users that are primarily typically doing the sales or quotations. It has all the capabilities. It can be used with quick form, and of course the data then can be passed to a Quick Press user. Let's pick up with what else Quick Press will do. Now we move to punch design, where we highly automate the creation of cutting, bending, forming, all the different items, plus you can tailor them. When I mean tailor them, that means without programming anything. If you design dies differently to the next guy, even the guy that sits next to you, you can tweak the system to be slightly different with just some minor changes. We do this in all areas. Now, every data item we create is still a native SolidWorks item, so you can still use standard SolidWorks modification techniques. Plus, we'll look for all the commercially available punches we can. For instance, we can automatically pick up on the press setup in regards to the punch length, the penetration, and the diameter, and we'll go seek in your favorite manufacturer's library if we can find a punch for that. If we can, we'll bring it in and assemble it all automatically. This whole concept of customization is summarized in what we call a PRL, a production ready library. And a production ready library is a catch-22. Is it production ready for somebody or is it for me? So the idea here is it's about you and it's about your company's style. You can adapt pretty much any type of component, subassembly, part, drawings, all to your style once, and then we'll recreate it every time you see something similar. So here we have an example of a simple PRL. It's the standard components placement based upon the strip length, width, and thickness. All you do is pick on the strip. The rest of it is created for you, including the holes through the die. Stroke length in this case is a very simple example where the stroke length is being picked up for the current job, so you don't have to mess with it. You just insert the component. Here we have a bend set. In this case, there's a lot of other things that are going on, but the only thing the user has to do is pick the two bends. Everything else updates, including the punch length, the die plate thickness, the width of the bend, the thickness of the material, the angles, and so on. And then, just to remind you, we're not just doing 3D here. We're creating the 2D for you. As we know, you can go do die design overseas. You get the emails all the time, right? $2 to $4 an hour. That's because it's very fundamental. We have to cut that stuff out. We have to automatically do that. To add true value and still have profitability, we need to get to the heart and soul of the design. So we're helping you do that by automating the redundant, simple behaviors. In the die set area, that's very similar. You may have a custom setup for each press or per customer per press and the certain components that they want to use versus the next guy. So what we can do is we can tailor the templates, what we call a PRL design die set, and this can support more than progressive die. It could be for stage, tooling, transfer, compound, anything. Because if you can draw it once, which is pretty simple to do, to draw these shapes, we can automate it. Now, we do much more in the die set. We will create all the holes for you throughout the entire process. So you just tell us the clearances, and we'll do the interference detection, and we can even animate it and assemble it in a very structured assembly. Anytime you want to add a component, I just want to reinforce the fact that you do not have to be a programmer. This is basically what all competitors will do. In your world, you'll say, well, you can do that, but they're not going to tell you you have to learn C++ or Visual Basic to learn it. All you have to do is know how to use SolidWorks. In the 2D side of it, throughout the entire process, we've enhanced the sketching environment, which is just 2D. Of course, SolidWorks has lines, arcs, circles, splines, all that, dimensioning, and all that. What we've done is built upon that, such as automating corner undercuts and corner treatments or mismatches, die insert opening, bounding box tools, all types of automation routines that are very tedious to do, not hard, but tedious, and even all the way down to spline. If you want to convert a spline back to arcs and lines with a bunch of tangent conditions, all that can be done with a simple click. Now on the detailing side, we did mention the drafting is highly automated, but I also want to add a couple other things. We will automatically calculate the stock size for all your material within your die set. So you can see why our customers are not only quoting and doing a 3D strip with their proposal, they can quickly lay out a basic die with all the raw materials calculated before they even present it to their client. And they're doing that quicker than they would do in 2D and more accurately, to say the least. We do have a couple other applications that fit different needs and different budgets. One of them is a very simple introductory tool called 3D Quick Quote. This is a geometric unfolder that will unfold any surface or solid very quickly, and within seconds you'll get a blank. And with that you'll get a report, and this report is in Excel. So you can take this data and it will, of course, Quick Quote will automatically scan the part and look for material utilization, cutting length, number of holes, individual hole perimeters, optimize orientation, a few screenshots. Of course, you can tailor it because it's Excel, so you can customize it for the look and feel, and of course you can put different types of information such as costing information. Now, for more complex unforming, or unfolding I should say, we have 3D Quick Form. This is for the complex forming areas of a part, and it could be just a region. It doesn't have to be the whole part. We can do a number of trials or a number of projects per part. We do offer something very unique in this price zone, and that's holding constraints. The ability to constrain part of the part while the rest of it flows. This technology is proven technology by ESI. You may have heard of them by the name of PAM stamp. We partner with them, actually OEM their mathematical engine that solves this, and they're the leading provider of metal forming validation software in the world. In the short period of time we've been on the market, we've got clear over 300 plus customers, and of course these range from very entry-level small tool and die shops that are trying to exceed their competition today, and other larger companies that are already the leaders in the market and they want to maintain their leadership. Of course, this also includes the educational and vocational world. So we are training the next generation die designers how to utilize this technology and to be more competitive long term. So at this point, I want to jump into a live presentation and finish up with doing something from scratch